Hi everyone, and welcome back to this new installment of the Flower tutorial series. Last episode we looked at a very simple example using TensorFlow, and today we're going to focus on a similar example but writing our code using PyTorch. So first, it's important to realize that PyTorch is quite more verbose than TensorFlow. So the centralized part of the implementation is going to take a bit more time to write. That's why we're going to speed it up, because we want to focus on the federated part of the implementation. If you want to follow along this tutorial, you will first need to install Flower, then Torch and Torch Vision as well. There we go. So once the installation is done, I'll go ahead and create a new file, centralized.py, and this file will contain everything related to the centralized learning. So this is just the PyTorch code that we put in a separate file to make it cleaner. And this is not relevant for federated learning, so I'll probably speed that part up and catch you guys afterwards. Alright, so now we should have everything ready for the centralized case. So here we first define the net. So this is just the model architecture. And then we define a few functions. The train function is just to train the model for a given number of epochs on a given train set. And there's the test function, which evaluates the function and computes the loss and accuracy of the model on a given test set. And finally, some utility functions to return the data loaders for the training set and the test set, and also to return the model with also converted to the correct device. And so this should be enough to train the model in a centralized way. And we can see here I've just written a few steps where we train the model for 5 epochs and then test it and print the results. Alright, so if we go over to the terminal, now if I do Python centralized, so it should first download the data. It should be quite quick. Alright, okay, nice. So now we have our loss and accuracy. So the accuracy is not excellent, but for 5 epochs it's pretty good, especially because the Cypher 10 task is quite hard. So yeah, this is for centralized training. And now once we have all those functions, we can actually start writing the code for our client. So if I create my client.py, so the first things we're going to import are actually from the centralized file. So we'll do from centralized, I'm going to import, so load data, load model, and then train and test. And that should be all we need from there. And then obviously I'm going to import Flower, so FLWR, and I'm just going to import it as FL to make it shorter during when I write it. Okay, so the first thing we are going to need for this client file is a new function called set parameters. And this is just going to be a utility function to give us the same kind of functionality we had with TensorFlow, where with TensorFlow we could just update the weights easily. In PyTorch, this is not written by default, so we have to write it by ourselves. And so this function will take a model as a parameter, and then the parameters we want to set to the model. And so this will actually return the model itself. I'm just not gonna put the typing here to make it more simple. Okay, so the first thing we're gonna do is create a parameters dict, which is going to be so the input model state dict. The state dict contains some information about the layers of the model as keys, and then as values it should be the parameters, but we actually want to update those parameters. So what we're going to do is to only take the keys and to associate them with the new parameters. And then to create the state dict itself, it needs to be an ordered dict, dict. And the only thing we need to do, so we're going to use the same key. So I'm going to write it like this, so it's a bit easier to follow. So we're going to take the keys and values from the parents dict, and we're going to associate each key to the value converted to a torch tensor. So we also need to import torch here. Torch and also ordered. Yeah, move that down here. Okay, so now we have a valid state dict, and we only need to load it into our model. So load state dict, and we're going to set the option strict to true, because the models should always be of the same dimensions and should contain the same layers. Okay, so that's good. Yeah, and we can even return the model. I don't think it's necessary to actually return it, so we can pass the object itself to the function. Okay, so now that we have this set parameters utility function, if we want to update the weights of the model, we can just, first we're going to define our model. So in this case, it's going to be load model. Okay, and then we can also download the data. So train loader test loader load data. Here we go. Okay, and now say we want to update the model, we can just do set parameters, then give our net, and then the new parameters we want to set it. And this is going to be very useful in our Flower client. Okay, so the Flower client is going to be a subclass of fl.client.numpy client. There we go. And just as in the TensorFlow example, we're going to first define getParameters function, which takes just a config as argument. And in this case, we can't just do model.getParameters because this function is not implemented in PyTorch. We need to return the parameters manually. So we first convert them and pass them to the CPU in order to be able to convert them to NumPy. And then this is just using the state dict items. All right, so we're accessing the state dict of the model that we define here, and then we're only taking the values which correspond to the parameters of this model, of this state dict, sorry, and converting them to NumPy arrays and returning this as a list. All right, so this function is done, and then we can focus on the next one, which is going to be the fit function, which takes parameters and a config. We'll actually ignore the config because we don't need it. And in this function, what we do is we set the parameters to the parameters we just received from the server. We can actually do net equals that. And then train. I'm just going to train it for one epoch by default. We could do more, but then it takes a bit longer. In here, we're going to just return get parameters, and we need to pass in the config, which is empty in this case. Then the length of the train loader. So train loader. All right. Dataset actually. And this last one is if we would want to return metrics. In this case, we don't return anything because we don't compute the metrics in the training function. So this should be good. And finally, the evaluate function, which takes parameters as well and config. The only difference here, I'm actually going to remove this net equals flip because it shouldn't be necessary. Right. And here, so we're going to do very similarly. We set the parameters given by the server, and we update the model with it. And then instead of train, we're going to test, and the test returns loss and accuracy. Test, and then net and test loader. All right. Note that those variables, net and test loader, are defined globally, which is not necessarily the best practice. It's just to show quickly how it would work. But here we could have an init function for the client where we actually pass in those models, this model and those data sets. Right. And here we're going to return so first the loss, then the length of the test loader dataset, and finally the metric is dict. And this time we actually calculated the accuracy, so we can return this. Okay, now we should have everything needed for our client to work. In order to start it, we can just add the fl client start numpy client. In this case, we actually use the numpy client wrappers, so here and here, to make it a bit simpler. Maybe we'll do a tutorial later on talking about the differences between the raw Flower client and the NumPy client, but this is out of the scope of this tutorial. Okay, and then we just need to pass in the client we want to use. In this case, it's the Flower client we defined above. All right, so if we start this client, it will try to it will start up the NumPy client and try to connect to this address, but now at the moment there is nothing at this address, and this is why we need to create the server .py file, which is going to be very basic. I'm just going to import Flower as fl, and then just server.start server. And here the server address is actually going to be 0.0.0.0 This is just so other machines on the same network can access this server as well. But in my case, we're just going to be using we're going to start up the clients and the server on the same machine, so it doesn't matter too much. Alright. And for the strategy, we can use strategy.fed average. We're going to use fed average with default parameters. Alright, so now we should have everything. I don't know if I've missed any imports here. I mean, we're going to try and see how it goes. So on this left terminal, I'm going to start up the server. There we go. And then here, I'm going to start one client and the other. So here, okay. Oh, I guess, yeah. There's a typo, obviously. Hopefully it's the only one. Here, yeah. Alright, just checking quickly. Let's see how it goes. So again, we start the server and then the clients. Okay, so now they're connected. we've established a connection. The server actually requested initial parameters from one of the clients and then sent back those parameters it initialized to the other client as well. And then it was able to start the fit round with those parameters. So the clients run the training locally, sent back their the resulting parameters to the server, then the server aggregates them. So after this fit round, and it sends back the aggregated weights to the two clients, which then run the test function, the evaluate function, and send back the results to the server, and this ends the first round, and then they start this whole process again. So we've only have 3 rounds, so it should be quite quick. It's not going to be comparable to the centralized results because we have less rounds, but here we can see that the loss decreases quite a bit. And so one thing that you might notice here is that we don't actually have the accuracy displayed. This is something I didn't touch upon on the last tutorial, but I will quickly go through it now. So the first thing we're going to need to do here is actually to modify our server file. We're going to add a function. We're going to call it weighted average, because we actually need to provide a way for our strategy to know what to do with the different results it's gonna receive in those metric states, because anything can be passed inside the metrics dictionary. So here we're first gonna use this. So num examples times accuracy. Num example is going to be from metrics and n as well, metrics, okay, and then we're going to list the examples here, metrics, and finally we can just return, so we're going to return it as a dict, with accuracy being the sum of the accuracies over the sum of all examples. Alright, now we just need to pass it to our strategy, and the argument for the strategy is going to be evaluate metrics aggregation function, and alright. Okay, perfect, so that should be it. Yep. Now if I start up the server again and my 2 clients, we're going to run exactly the same workload, except that now we're going to have at the end the metrics. It's going to be just the weighted average of the metrics from the 2 clients. Okay, so now it should finish quickly. It's in the last round of evaluation. Perfect. And now we can see the accuracy, and it's actually quite comparable to what we had in the centralized case. I think we had 49, if I remember correctly. Okay, nice. So there you have it. This is everything you need to go from centralized to federated with PyTorch. This was a very quick and dirty example. There's a lot more to it, and we'll try to release many tutorials to go through more topics and go more in depth on certain subjects. As for now, be sure to subscribe to the channel and especially tell us what you would like to see next. And one thing I wanted to touch upon as well was to go over the GitHub repo. It's very important for us that you give us a star on GitHub. Note that on the website here we have this button, but it does not automatically star. You actually need to press here afterwards. And this is also very important for us to be able to see the community grow and to be able to understand better the users and the needs of the community. Yeah, that's it on my side. See you guys.